Hello, I hope you're doing well. Um, Today's lesson today is going to be on moments, and we're talking about the moments in physics, not the way you describe a moment in time. um, so in physics, let's start off with the definition. So, the definition of a moment in physics is a force that produces a turning effect on an object. So, and by turning effect, I mean anti-clockwise or clockwise. So, moving, let's say this highlighter um from let me check the count from anti-clockwise like this or clockwise. Um, I think I got that the right way round. Anyway, um, if you're wondering, for now, before we get to the slightly more complicated part, let's think of a real life example where you would use moments. So I have here a picture of a door, and to make my life explaining this a bit easier, for now, um, let's just say that the pivot or the hinge of the door, um, this is a pivot, um, or in a more fancier word, a fulcrum, um, of the door is here. And I imagine you yourself would open a door, like any sort of door, ignoring the automatic ones, that's a bit boring. I imagine you'd open any door like this, um, from the handle, or if there is no handle anyway, you'd push the door as far away as possible from the hinges. And obviously, if you think about it, if you try to push open the door from here, or from here, or from here, any of those three spots, um, you'd find it very hard or next to impossible, um, to open the door. So yeah, you would. So I'd imagine you definitely go for pushing the door as far away as possible from the hinge. So let's incorporate a bit of maths into this now. And for this, we are going to make a top-down perspective, or I'm going to draw a top-down perspective of you. I'm going to draw a top-down perspective of you opening the door. So let's say that the black line is the top-down perspective of the door, and let's say that this is your hand trying to let's say that this is your hand trying to push open the door this way. So along the path that you push the door is going to go along the path of this blue dotted line. So anti-clockwise essentially from this top-down point of view. Um, if you're wondering how that all works out, you could place your finger by the pivots and look at the direction of the force, and from that direction of the force you can work out where it's going that way, because since it's going up, and imagine that that part of the object stays still, you can see that it goes anti-clockwise. It may take a bit of practice, but you'll get the hang of it. So yeah, let's put some numbers in, and I'll explain how to calculate the moment of the force. So let's say this is you. So let's say that you are exerting a force of 500 newtons onto the door, and if you're not familiar with what the N means, N is for newtons, and that's also the unit for force. And let's say that from the top down perspective of the door, that the door is 2 meters long. To calculate the moment, or more fancier words, the torque, you would do the force 500 multiplied by the perpendicular distance of the door, and if you do 500 times 2, you would get 1,000. And from this we can say that the moment of a force is equal to the force multiplied by the perpendicular distance. And the reason why, and well, first of all, in case you're not familiar, perpendicular means at a right angle. So this force that's going upwards is at a right angle to the pivot, or the hinge of the door. So this is essentially 90 degrees, and that is that's the formula to calculate the force. And what I was going to say next was it has to be perpendicular, otherwise, as I said earlier, if you decide to, for some reason, exert your force here instead, because the distance that the force is at away from the pivot, or otherwise the perpendicular distance from the pivot, is 0. And as you know, anything multiplied by 0 is 0. So you wouldn't, as I said, you wouldn't obviously open the door by where the hinge is, otherwise it just won't work. So if you apply a force right onto the pivot, the moment is 0. And same case, even if you decide to let me just redraw the door. So this is the door, the same exact door of 2 meters, and say that this is the hinge of the door. The door would also not open if you decide to exert a force like that, or like that. Why, you may ask? It's because the force is here. Let's just use the one to the right. So the forces here are not at right angles to the door. It's, as you can see, it's literally on the same line as the door. So it's 0 degrees, and it's not the perpendicular distance, so that will make our perpendicular distance 0 again. So therefore, once again, the moment is going to be 0. And this is the basics of how to calculate a moment. And before I go, I will give you some I'll give you some time to have a little bit of practice on how to calculate moments. So let's say that this is a hinge. No, sorry. Let's say that this is a handle to a door, and you need to push the handle downwards. So let's say this is you pushing the door downwards. And let's say you exert let's say you exert 1,000 newtons on this handle, and the handle is 1 meter, and this is where the pivot of the handle would be. From using the formula here, moment equals force times perpendicular distance. How you would go by calculating the moment here by using 1,000 multiplied by 1, which is just 1,000. And now I haven't gone through this yet, but the unit for moment is Newton meters, and I don't know if you're familiar with this yet, but if you would like a fun fact, Newton meter is the same as joules, the unit for energy. And in case you're also, and you might also be familiar with this, I don't know if you've been taught this yet, but you might be familiar with the concept of work done, and work done being force multiplied by the distance along the force, and the unit for force is newtons, and the unit for distance in physics that we use is meters, which if you did the algebra of that would be equal to Newton meters. But as you also know, work done is the units for work done is joules. So you could say that the unit for moment is joules, but people don't tend to do that. But anyway, that's the basics of calculating moments. I hope you enjoyed my very short, nearly 13-minute lesson, and I hope you have a good day. Bye bye.